Welcome back to Calculus 1. And this time, really, we are moving to the beginning, very beginning of calculus, section 2.2, the concept of limit. Concept of limit. And I copy and pasted those learning objectives from our textbook. Putting a simple way, everything it is about limit. Okay, at this moment, well, the way we find out a limit, there are two ways. And we can observe the limit from the graph of the function, and also we can use table values to find out the limit. So basically, these are the two ways we are going to illustrate in this section. And also the limit, hopefully if you are using the graph, you will see the limit could be one-sided or two-sided, or indeed many times it could be just both. Okay, there are one-sided limits and two-sided limits, and also, two-sided limits, basically, which means the left limit and the right limit, they are consistent, they are matched, so they form a single limit. And how about let's start from the graph from the textbook first. Let's use the graph. Let's do some intuitive approach about limit. And I'm having three graphs. Basically, they are for three different functions. This first one, it is a rational function. Interesting enough, it is a rational function, but anyway, in this case, believe it or not, the graph of the function, it is a straight line. And also, I suppose if you know those algebraic formula very well, indeed, this function can be reduced, can be simplified into a single function, x plus 2. So it is a straight line. It is a straight line, okay. The only trick here is because we do have this x minus 2 arranged in the denominator. So you may want to know x cannot be 2. The graph, it is a straight line. There's a little circle here, empty circle. It is for x equal 2 because x equal 2 is not defined. So this little empty circle simply means this point it is really not on the graph. It is really not on the graph. But anyway, let's focus a little bit more on for the graph right here at x equal 2. I'm tracing the pattern. I'm trying to follow the pattern of the graph for x approaching 2 from left, from this direction, from left of this point 2. As you can tell, overall the pattern, it is pushing the something into this empty circle there, right? So indeed, from this observation, we do have a left side limit. As x approaching to 2, the function, it is pushing to this circle, or really the limit, the left side limit of this function, it is 4 at this point here. And also in this graph, from the right, x approaching to 2, from the right, all the points to the right of this 2 here. And still you are going to track from the line. And I'm still seeing the same pattern. Everything, it is being pushed into this empty circle. Okay. In this case, the left side limit, right side limit, they turn out to be the same. So indeed, we say the limit of this function as x approaching to 2, it is 4. The limit of this expression, which is a function, the limit of this function as x approaching to 2 is 4. And also, one thing you may want to know, what's so tricky about here, because really the function value f of 2, it is not defined. So it is an unusual situation. It is an unusual situation. This is basically how we observe a limit from the graph. And how about, well, I guess there should be a lot of questions. But anyway, let's just move on to the second graph. Let's move on to the second graph. Okay. Second graph, it is for the function of the absolute value of x minus 2 over x minus 2. And first, I still want to say, hopefully you already observed from part A, the first part. Okay, the function, it is not defined at x equal 2. So for the lower part, there's an empty circle. For the upper part, there's an empty circle. At x equals 2, it is complicated. And then if we follow the same approach like we did from this part of the graph, we track how x changes from left, x approaching to 2 from left. All the values x less than 2. Indeed, if you look at the graph, actually this is for the horizontal line for y equals -1. Okay, basically we can see the pattern as x approaching to 2, everything it is being pushed into this empty circle, which means the limit of this function as x approaching to 2, we write in this fashion, okay, x approaching to 2 from left, x approaching to 2 minus, which means to the left, and it is pushing to this empty circle, the lower part of the empty circle, which has a y value of -1. So we say the left side limit, it is -1. And then we write in this fashion, x approaching to 2 minus. And also we look at the other half of the graph, it is the upper line here. Still it is for the line y equals 1, but the empty circle means at x equals 2, the function is not defined. There is not a single value for f of 2. But we look at the pattern of the function, and as I'm saying, I would expect as x getting really close to 2, everything it is being pushed into this empty circle. That means this expression, it is approaching to 1. So in this case, we say the function has a right side limit, and we write as x approaching to 2 plus x approaching to 2, any value greater than 2, the function has a limit, which is 1. And now we are getting into a situation for this graph. The left limit and the right limit, they don't match, right? So we really don't want to say at this x equals 2, there are 2 limits. And we want to say if there's a limit, there's only 1. So in this case, we do have both two-sided limits. One side, the left side limit, right side limit, but we do not have a single limit. So the limit does not exist. The limit does not exist. Limit does not exist in this case. How about let's move to the third graph? Actually, we are still trying to focus on the situation when x is really close to 2. And this is the function 1 over x minus 2 squared. And this time, if you track closely, I hope it will make sense. As x moving from left to right, okay, moving from left to right, approaching to this number 2. Moving from left, approaching to this number 2. And the graph, it is going up, right? Which means the function value, it is approaching, it's getting bigger and bigger. And mathematically, we say it is approaching to infinity. So for the third part of the graph, this is what I wrote here. As x approaching to 2 from left, actually from right, the same situation. I did not separate the left limit and the right limit. And hopefully it's easier to see from the graph. From right, we have the same situation. The graph, it is moving upward. So in this case, we simply can say as x approaching to 2, either way, from left or right, the function, it is approaching to infinity. And we write in this fashion. This is the so-called infinite limit. We will have a little more discussion about the infinite limit just in a moment. So far so good. I hope you can observe, you got some idea how to observe a limit from the graph of the function if there is a graph. And again, in the first part A, we observe there is a limit, simpler part. Because from left, from right, when you have x approaching to a value, it is always a situation x could approach that value from left or right. But anyway, in this case, from left or right, they don't make a difference. And overall, I'm seeing the pattern of the function. It is approaching to this empty circle with the y value 4 here. So we say the limit as x approaching to 2, it is 4. And in the second case, we do have two one-sided limits. But anyway, overall, there's not a single limit. There's not a single limit. The limit does not exist at x equal 2. And the third case, maybe more complicated because there's infinity involved. Infinity, it simply denotes the situation. The numbers are getting bigger and bigger. So it is clear to me as x approaching to 2 from left, and the numbers getting, the y values are getting bigger and bigger. X approaching to 2 from right, still the y values are getting bigger and big. So we simply say this time the function has an infinite limit, and we write in this fashion. By the way, it's worth to mention the way to write a limit notation. You want to be very careful because we are doing this entire thing online. I cannot ask you to do writing right now. But anyway, I would appreciate if you are watching the video. You may want to give a pause, try to rewrite each of the limit I have on the notes, and hopefully I really believe that will help better understand. This is the entire limit x approaching to 2 from left or right, and this is for the right limit x approaching to 2 from right, all the values bigger than 2. This means x approaching to 2 from left, all the x values less than 2. And case A, actually, it is the easy one, right? And from left or right, we have the same observation. So this is a very intuitive approach about the limits. And certainly we will do more about the introduction of limits. Thank you for watching.